Hello, everyone. So there have been a lot of cross-platform talks today, and I have another one for you. So I am Rohan Taneja. I'm a software engineer at Delivery Hero in Berlin. I am a native Android developer who recently fell in love with Flutter. And I'm here to tell you why I fell in love with Flutter and how you may do that as well. So my topic is why Flutter is the mobile SDK we deserve, high time now, but also the one that we need right now. What's so special about right now? So before we begin, may I have a show of hands? How many of you are native Android developers? Okay, half of you. iOS, React Native, and designers? Okay, one. Great. So Flutter is a mobile SDK from Google that lets you build beautiful native apps in record time. So those of you who are React Native developers and thinking another cross-platform SDK, do we really need this? React Native is the winner. Hold on for the next 40 minutes. I may change that thought. So Flutter helps you build beautiful native apps in record time. A couple of key terms over there: native apps, record time. And the example on the right is a Flutter app running on iOS and Android. You can see the transitions are pretty smooth, and this is just the beginning. It just gets better from here. So before we dive into Flutter, let's just see why is it something that we need right now. So recently, Google announced that Android is running on 2 billion active devices per month. Soon after that, Apple announced that iOS is running on 1 billion active devices per month. That means that if you're only building for Android, you're losing out on 1/3 of your potential revenue. If you're only building for iOS, you're losing out on 2/3. Basic math. And if you have separate teams of both of them, that means you are using twice the time and effort in terms of development resources. Not so good. But still, if you use cross-platform, you use only half the development time and effort, and let's say you're sold on the idea of using cross-platform. But still, that has nothing to do with Flutter. There's no reason why you should try Flutter. So talking about cross-platform, let's dig into the ones that currently exist or the ones that got immediate fame. The first one was probably iNic. The problem highlighted in red is that it uses a web view. Performance issues straight away. Other than that, it also uses a JavaScript bridge. And anytime you go over the bridge, it causes a delay, performance issues again. Not so good. Then we had React Native. No web view, great. It uses OEM widgets, good job. But it still had a JavaScript bridge. It's good. It's really good for a lot of people, unlike Airbnb, but it still has some animation delays due to that bridge. So that means cross-platform frameworks are somewhat like this. They're not very intelligent. They have a lot of drawbacks. They may cause stability issues, but still, I don't know why people still prefer them. This is what OEM Android and iOS looks like. You'll hear the term OEM a lot. That's because Flutter is native as well. So just calling Android and iOS development as native is not right. So I'll refer to it as OEM then and again. So they did it right. They used the OEM views, no bridge, no web view, perfect. That's what we need. But there are some challenges involved with going with the OEM approach or with the cross-platform iNic and React Native approach. With OEM, you have to fund two teams. You have an iOS team and an Android team. So there will be some inconsistency between both the teams. With cross-platforms such as iNic and React Native, there are performance issues, and you have that non-native look and feel every now and then, even though it's good, but not that good. So before we dive into Flutter, let's just see how an app comes to life. So the designer on the left and the developer on the right. Sorry for the cliched image, but that's the best that I could find. So the designer comes up with this great idea for an app and talks to the developer and asks him, can you build this? And we as developers have a tendency to say no to our designers. That's because it's tough. And soon after we say no, we do either of the two things. Either we doze off, or we start celebrating, feeling that we have avoided a really complex task. We would have had to work on those complex designs, which look great in real life, but it's tough to work on them. So that's when this guy steps in. And this guy, with his ever diplomatic approach, comes to you and says, the management has approved the designs, so you'll have to work on them. And then the product manager asks you, would you be able to do that today? or not, if not today, when would you be able to do that? And as developers, what do we say to product managers? Not today. So that's how this all builds up. The problem is not that we engineers and developers don't like to work on those great designs. The problem is that it's really tough. Those designs look great on the Sketch app, but when you try to build them up, they take time. The problem is that developers like us have been solving trivial problems for far too long. Have you tried using custom views with custom fonts in Android? A basic functionality that's needed in every project, but still a hassle. Or have you tried understanding the fragment backstack? Still an issue for me. Then you have basic animations that look good in the design again, but implementing those, not so easy. But even if you get over all these, there are some device-specific issues. But the problem is not that you are spending your time solving these problems. It's great you're solving a problem. The problem is that these problems do not add any business value. They do not put money into your client's pocket. They do not push any new features of your product every week. So that makes you wonder, does a developer's life need to be that hard? Shouldn't an engineer be focusing on writing better maintainable code, something that scales, or something that allows you to ship new features every 2 weeks? That's where Flutter steps in. So like I said, Flutter helps you build beautiful native apps in record time. We'll go over all 4 of these one by one. So how does it build apps? Flutter does not use a web view. It does not use a JavaScript bridge. Flutter draws everything on the screen at runtime. So immediately when you think about its drawing on the screen, how does it do that? It does that because it uses a renderer. You can see that there's no web view, there's no JavaScript bridge, but there's a rendering engine. It directly communicates with native code and prints out everything on the canvas directly. There's no intermediate. Then you have access to platform channels like location, audio, camera, and all that stuff. So no web view, no JavaScript, all those performance issues gone. That's what Flutter is. So you wonder, how does the rendering take place? This is what the Flutter architecture looks like. The framework is written entirely in Dart. But there's an engine at the bottom. That's where the rendering part is done using. It uses an engine called Skia, which is also what the Unity game engine is based on. And that's how rendering happens. This engine is shipped with every APK or IPA file. It goes in every app that's built in Flutter. That's how it prints directly, draws everything directly on the canvas. And Flutter uses Dart. Dart, like most of the people thought, and so did I, is a dead language. It's not. It's used highly internally at Google. And now with Flutter, it's used in the third-party apps as well. So the Google team wanted to test out Dart, how easy it is for people who know Kotlin or Swift or some other language. So they went to some other team in the Google office, and they just gave them this syntax. They didn't tell them what it's called, or they didn't give them any docs. And the other team, which was supposed to use this language, started to build Flutter apps on the fly. A day later, when the Google Dart team came back to them, and they asked, do you even know what language you're using? The other team said, no. It's just that it's something that came too easily to them, since they already knew Swift, Java, Kotlin, or some other language. That's how easy Dart is. You don't need to jump into Dart for a month and then try Flutter. You can dive into it straight away because it's easy. So how does the drawing on the screen at runtime actually help Flutter? So you'll see 4 screenshots from 4 apps in the next slides, and just try and identify what's common among the Android and iOS versions. So this is the first one, a meditation sort of app. This is something for perfumes and cosmetics. This is some music app, and a property real estate app or something of that sort. OK. So these are not Flutter apps. They were built using native Android and native iOS. And these are award-winning apps. Can anyone identify what's similar between them? The fact that it's similar is that they look identical on Android and iOS. You don't see a colored toolbar on Android, and you don't see a white toolbar on iOS. They look identical. They may not be following the best practices, but these are award-winning apps. These are popular apps. These are what your users want. So these look identical on Android and iOS. And since Flutter can draw everything on the screen at runtime, you don't need to put twice the effort with the Android team and iOS team. Just use Flutter, ship it to both, and you get the same thing on both of them. Here's another example of how drawing during runtime can help. So let's say the client comes to you and says, I am an Android user. I think that the WhatsApp app on Android looks great. The iOS one looks ugly. But my users are all iOS. So can you make the Android one look like iOS? So he's asking for something like this. Looks ugly, but that's what the users want. So with Android and iOS, if you try to do this, you'll be scratching your heads the whole day. With Flutter, it's drawing everything on the screen. No matter which device you give it, it'll just paint that. So you can also have the bounce effort of iOS on an Android device. You can have the glow effort of Android on an iOS device. It does not care which device is it running on. If you can do that, you can also do this. You can have the Android version running on an iPhone. Example number 3. So this is the story of a huge MNC who were doing not so well in the phones market, and they called a meeting of the top management. And they were asking for ideas. How do we get better sales? So someone proposed, let's have a dual camera. Someone said, let's have edge-to-edge display. Then this genius stepped in. He said, why don't we just override all the system fonts? And this is what the app started to look like. So I won't be naming the MNC. I'm sure all of you know. But no matter how hard you try, you can't override these fonts. Your apps may look great, but the fonts look ugly. You cannot help that. With Flutter, you get rid of this problem as well. Override all the system fonts that you want. Flutter does not use them. And another great thing, material design came out in 2014. This is a Jelly Bean device that's from 2012 that does not support material design. So with Flutter, you can have material design run on a Jelly Bean device as well. That was launched before material design itself came out. So that's the version given over there. It's something that does not support material design, but you have the material design app running on the same phone. Drawing on the screen at runtime, everything works. Another thing that you may have noticed in the previous screenshots is that those apps are beautiful. And you could see that each app represents what purpose it's trying to solve. The cosmetics app, it was extremely brand-driven. You could immediately identify that this has something to do with cosmetics. So with Flutter, you can have brand-driven apps. You can go deep down into the framework, customize any widget that you want. So it's highly customizable. You want a square floating action button, you can have that. And it is jank-free. More on that later, but with React Native, the core problem was animations. The rest of the stuff worked well. But with Flutter, it's no longer the case. Even the animations work brilliantly. But still, how does it do native apps if it's not using any of the native Android and iOS views? So again, this is possible because of an amazing advantage that Dart offers. Dart gives you ahead of time compilation. What that does is that it compiles directly to native ARM code for both Android and iOS. There's no intermediate again in between. So there's no reason why it can't have ARM code. And since it directly compiles to machine code, that's what native is. That's why Flutter apps are native. Google did another experiment with the Flutter team. So there was an existing team from the Google CRM team, and they had their Android app working. They wanted to build an iOS app, but they didn't want to go to a third party and get it done. So they came to the Flutter team, and they asked them if you can do it. So they had an existing Android app, and they wanted to get the iOS one done. So what the Flutter team did was, they built the iOS app on Flutter, but you get the Android one for free. So they actually took down the native Android app and replaced it with the Flutter app on Android as well. And the existing users could not tell the difference. That shows that there is no performance issue. I was using this app a day before that's on native Android. The next day, the Flutter team ships a completely different Flutter app to me with the same UI, the same performance, and I, as a user, cannot tell the difference. So we have covered that it builds great apps, beautiful apps, and native apps. But how does it do it in record time? So this is a simple UI that you'll see in your day-to-day lives. It has a toolbar, a navigation drawer, a menu item, and a floating action button. How much time do you think would something like this take on native or OEM Android? Any guesses? 20 minutes, 15 minutes? Any guess? OK, let's just see what the steps are, and then we'll get an estimate. So you feel that that's easy, just use the basic template. But you cannot use that. If you're comparing Android and Flutter, let's just be fair and compare when we did not have the template. So you have the project with the main activity already there. You also have the corresponding layout. Then you add your menu XML so that you can have that edit icon on the right top. When you do that, you realize that you're using an app bar, but you want to have your own toolbar. Nobody uses the default app bar these days. So you add the toolbar. Next, you want to handle clicks on that edit icon, so you override this method in your activity. Then you think about adding the drawer, but you cannot do that because you need the library dependency. Sucks. Then you finally think about adding the drawer, but you still cannot do that. The default code has a constraint layout. For the drawer, you need the drawer layout. So you replace the code in your XML file. And finally, you add a navigation drawer. The one thing left, floating action button. Then you add it easily. So how much time do you think this takes? An hour, OK. Someone who is vouching for Android and saying less? Half an hour, OK. So I asked this to a lot of developers, and some were really cool and really senior. Those who said, I can do this in 5, I can do this in 10. So the average came out to be 15. But the answers that I got here are 1 hour and half an hour. On React Native, the average answer that I got was 10 minutes. And in those 10 minutes, you get it on both iOS and Android. I'm not sure how valid this answer was, but that's what I got. So let's just see how quickly that would be in Flutter. So enough of telling. Let's just do some live coding. So I have an IDE open here that's called IntelliJ, quite popular now. There's an iOS simulator on the left and Android one on the right. I just created a new project, nothing fancy. But we'll do this the right way. I have a stopwatch ready. I'll start this, and let's see how much time it takes. Do I need to tell you anything before that? Yeah. So this will be completely Dart code. There's only a main method over there. That's the starting point for usually all the languages, and that's where we'll begin. OK, before that, I need to take some guesses. How much time would this take? I shouldn't have asked that. OK, let's begin. I'll also walk you through what I'm doing as I do it. So I need to import the material package first. And that gives me access to a method called runApp, which is the base method for your Flutter app to run. Use some cool shortcuts, and let's just run this. Take some time. But we can continue working on our code. So I add a scaffold. This gives me access to widgets like the app bar, the floating action button, and other stuff. And I wrap it up with the material app widget. Just do some clean formatting. Yeah, looks nice. OK, so I have a blank app. Doesn't look so good. So I have an app bar. I add that. And I press one button. I'm going to do that in 3, 2, 1, go. So you see your app bar on both iOS and Android in 700 milliseconds. I want to add a title. Let's just call it Flutter. Oh, that's quick. Let's add a floating action button. Format it nicely. And we have that. Oh, we have a star on the floating action button. The drawer is the toughest part in Android. Add the dependency, then add the drawer. It's equally tough in Flutter as well. I type in this line. Oh, I get the drawer. Quite tough. And the only thing that I'm left with is the menu item. That's tough on Android. Let's just format it well, see what it shows. Nothing. So this is a good thing. You see this crash on the screen. It displays the crash on the screen because it can draw anything on the screen. And you fix the error. Let's just give it a good color. Format it well, press this button, and you have the icon back. And we did all of this in just over 2 minutes. Even if we add the error, we could fix that, and we get the edit icon, we get the floating action button, we get the drawer, everything that we needed. It's in 2 minutes and 9 seconds, but it's on both iOS and Android. It's not on a single platform. So for a single platform, this takes just over a minute. So that's how quick this really is. If you want to see another example of that error, here it is. So I have double quotes for a string. Oops, did something move? So you have the error, you see the exact line that it shows you the error is. So as a developer, you can take this to another one and ask him what's wrong. You don't need to carry the whole laptop and show him the logs. You fix it at that moment itself. Let's just change the text to see if it actually worked. So it changes the UI for you, and it fixes the error as well in 600 milliseconds. So that's how good Flutter is. So we built the same UI. Results from Google showed that Flutter was actually 1.8 times faster than using Android and iOS. 1.8 times faster, and you get it on both the platforms, not a single one. It utilized 50% lesser code, and you get one app for free. So this screenshot is for situations when the live coding part doesn't work, but thankfully it did. So how do we do it? How does the quick refreshing part work? So since Flutter uses Dart, we have already covered how it uses ahead-of-time compilation to give you native apps, but it also has just-in-time compilation. And that gives you access to stateful hot reload. Stateful because even if you had the error, you fixed it, but the app remained in the same state. The error was fixed. This is extremely useful when you're 10 screens down in your app and you're debugging over there. You make a fix, and if you do this on Android, even if you press instant run, it goes to the first screen. You go back to the 10th screen and see if it actually worked. But with Flutter, since it is stateful hot reload, it stays on the 10th screen. You fix the error, and it still stays on the 10th screen. So that saves a lot of time. So friend told me that stateful hot reload is like instant run, except for two things. Stateful hot reload actually works, and stateful hot reload is really, really fast. And we just witnessed that. OK, what are other cool things provided by Flutter? So it separates the UI from the state. That's why when we had an error in our UI, it got hold of the state, it let that be there, fixed the UI, and then it showed it again in the same state. And when you try and use this, when you try to understand what Flutter is and think that it's not using the Recyclerview from Android, so what about the Recyclerview Performance? That's great on Android. I love that. I don't want to miss out on that. So Flutter has that handled as well. It has recycling embedded in the whole framework. So you have a normal list view in Flutter, just like you have a normal list view in Android that does not do that recycling part. But you have a corresponding widget in Flutter that does the recycling part as the Recyclerview in Android. So most of the views that you use in your iOS or Android daily lives, 80% of those have already been recreated in Flutter as widgets. And it lets you build high-quality native apps. When I said that I'll talk about Django-free later, this is what I meant. Flutter promises to deliver 120 frames per second. Even though no device today can afford that, we can really do 60 FPS, but Flutter promises to do 120 FPS. Sometime in the future, we'll actually see that in action. So the problems that we had with OEM, Android, and iOS, with you must fund two apps, no longer there, use Flutter. You have inconsistent brand and features. There's only one team working on an app that ships to both Android and iOS. You don't have that problem anymore. But this is fixed by cross-platform as well. But Flutter fixed the cross-platform issues as well. There's no poor performance anymore, and it has that same native look and feel. And if you're quite rigid about using Android Studio, using Xcode, using Visual Studio Code, if you're from the React Native world, so Flutter is great. It lets you work on Flutter apps in all of those IDEs. They have plugins for Flutter in all three of those. I'm using IntelliJ since I come from an Android Studio background, and it works great for me. Flutter also has access to Firebase APIs. The previous talk was on Rust. You cannot use Firebase APIs with that because that's not supported. But Flutter is from Google. Firebase is from Google. So they already have that. Other than that, you have access to native Android APIs, iOS APIs. You can implement your own state management architecture. And you have access to material design, just like we showed in the live demo. Other than that, you have access to third-party Android and iOS SDKs as well. Some people say that the only problem with these new cross-platform frameworks is that the community isn't too big. For me, I haven't seen something boom so quickly. It's really good. It's still not a stable 1.0 version, but it already has close to 40,000 stars on GitHub. And if you actually visit that repository or see the number of blogs going around in the community these days, This is something that's going to be great for the future. Even though some people fear that it's a Google project, it may be abandoned at any time. But this is something that looks really good. So then the next question that people ask is, if it's so good, why are not people actually using it? You see on the left, Alibaba, one of the biggest companies in the world, is actually using it. They have integrated Flutter into their existing Android and iOS apps. So the most useful use case for the people around here is that they already have an Android and iOS app. They don't want to put in the effort to completely get rid of that and recreate their app on Flutter. You don't have to do that. Just have new sections or other sections that you want to replace built in Flutter. So you can integrate Flutter in your existing Android and iOS apps. That's what Alibaba is doing. Next, you have the Google team internally using Flutter with the Google AdWords and Google CRM app. Then Birch Finance and Hamilton Musical. So Hamilton is a music festival from the US, quite a big one. And they used Flutter when Flutter was still an alpha version. That's 1.5 years ago. And it worked brilliantly for them. And it does not have basic functions like UI and everything. It uses a custom camera for your Instagram filters type of functionality. It has a selfie cam app, and it uses stickers as well. This app is completely made in Flutter. But they use native Android and iOS SDKs as well to plug in a few features. They did this when Flutter was in alpha. 1.5 years ago, we have come a long way. Yeah, so they said that they launched as a featured app on iOS and Android within 3 months of writing their first line of Flutter code. So they didn't have any Dart knowledge. They learned that in 3 months, and they built this app from scratch in 3 months, when Flutter was still an alpha version. So let's do a small recap. Flutter uses Dart, great language, not dead. Everything is a widget in Flutter. So you see the material app over here, that's a widget. Scaffold is a widget. Drawer is a widget. Floating action button is a widget. That means that your whole app is a widget itself. You can replace this material app with a Cupertino app, and this would start looking like an iOS app. So everything's a widget. You get stateful hot reload. You get high-quality native apps. And you get one app for free. Basic cross-platform benefit. But you do this in record time. Does not use a web view, does not use a JavaScript bridge, and it does not use a virtual machine. For those who are wondering what this debug on the right top means, this one over here, that's because this is currently a debug version. The debug version uses a virtual machine that it needs for hot reload. When you release a released version of this app, that does not need hot reload. Yeah, so the release version does not make use of hot reload since it's already released, so that will have no VM. And that performance on the release app is also better. And it does not use any of the OEM Android or iOS views. It has its own widgets. And the best part, it's all open source. So if you feel that a community is not big enough, just dig into Flutter, file a few PRs, and you're part of the community that's building Flutter. OK. So that means, if it's really good, is this the perfect mobile SDK? No. It would be unfair to tell you all the advantages and not talk about what's not there yet. So the native Android and iOS app, the default size for that is a couple of MBs. The default Flutter app size is 4.7 MB. And that's because of this thing. This engine in the Flutter architecture is shipped with every APK and IPA file. So this has some size, and this goes with every app. So that's why your app is that large. But the Flutter team says that they haven't even begun optimizing for size. This is the default one. They'll move on that later on. Right now, they're planning to work on a stable 1.0 version that has more features. The other thing that's a little problematic for some people is feature completeness. Android has been 10 years into existence. It has a lot of features, a lot of third-party SDKs. You won't get that immediately on Flutter. It will take time, but it will come. So feature completeness is an issue for few people. And some people say that it does not have a huge community. But just like we showed, just go around Twitter and search for Flutter, and you see the number of blogs and number of plugins people are writing for this thing. It's really, really good. Another problem is that, let's say Android comes out with a new API that has some new views and new APIs, methods that you can use. You cannot immediately use that in Flutter. Because Flutter does not have support for that, it's not using your native APIs immediately. But you can integrate Flutter with your existing apps. That means that you can have plugins that use those APIs, use the method channel, and get that in your Flutter app. So this is your iOS host. Flutter gives you a method channel that lets you communicate both ways. So you implement your API in iOS, you pass the details on to Flutter, and you can show it in Flutter or do the same thing in Flutter itself. Same for Android using the method channel. This is what the project structure for a Flutter app looks like. The library folder that you see over here, that's your Flutter code, main.dart, everything in Dart. You have the Android project and the iOS project in your Flutter project itself. So if you want to dig deep into your Android code, go and do that. You have your activities over there, the layouts over there. If you want to do the same with your view controllers in iOS, you can do that as well. So there's nothing stopping you. Next, I'm not sure how many of you have heard of Google Fuchsia, but Flutter is not restricted to Android and iOS. If it's drawing everything on the screen, what's stopping it from doing it on the TV or on your watch or on a Windows device? Fuchsia is rumored to be the next big OS that would replace Android. Rumored to be, not my words. So Flutter apps would be used on Fuchsia. Fuchsia would be running Flutter apps. And it's clear from their repository as well. So if you want to be future ready, you can give Flutter a shot and start building apps that may be used on other platforms as well. Flutter right now is a release preview 2 version. It used to be an alpha 1.5 years ago. Then we had 3 beta versions, release preview 1 2 months ago, and finally we have a release preview 2. There's a big event in London on the 4th of December that's called Flutter Live, and it's probably on that event that they'll launch 1.0, probably. I still don't know. So if you want to get started with Flutter, the best resource is the documentation. With Android, when I started out, the documentation had 0 screenshots, 0 GIFs or GIFs, whatever you call it. And I could see the code, but I could not visualize what it would do. Flutter has great documentation. It learned from all those mistakes, and it tackled those. And it has specific sections for Flutter for Android devs, iOS devs, React Native devs, and Xamarin devs now as well. So if you are coming from that background, you don't need to see the official documentation, the plain one. Just dig into what's suitable for you. Then we have the code labs from Google. Really basic, really easy to learn and pick up on. You should try that. There's a newsletter called Flutter Weekly. Just like I said, it's a great community, a lot of blogs coming out every week. That's a little tough to track. Just subscribe to this newsletter. And there are a couple of YouTube channels that are really, really good. MTech Viral has been doing this for 1.5 years since Flutter was in alpha. And there's a channel called Tensor Programming. You may have heard of it already. It's really good. They have great Flutter tutorials. If you're someone who's a course guy that I need a course to start working with Flutter, Udacity has a course for Flutter that's in partnership with Google. Covers all the basics. You may want to try that out. If you're someone like me who loves podcasts, just try out Fragmented Android Developer Podcast. They have 2 episodes for Flutter, and they're really, really good. They host a Google developer expert on their podcast, and those 2 episodes would tell you a lot. So there are also a couple of Facebook groups that give you help immediately in case Stack Overflow does not work. You also have a Gitter channel that was there initially. This Gitter chat has all the Google developer experts and the people who were working on Flutter initially. So if you want expert advice, go over here. Then you can reach out to your nearest GDG as well for organizing a Flutter study jam. I was looking for these yesterday in Poland, and I found 9 or 10 of these. So you can try that out. So if you want to click a picture, I'll just hold on for 2 seconds. OK, so this is a blog that I wrote a long time ago, because that's what I struggled with. I realized that Flutter is good, but where do I start learning? So all of the images that you just saw, you'll find those in this blog as well. So if you were taking pictures, you wasted your own time. So, and then we have 2 blogs from Wim Lehler, who's on the Flutter team, great guy. A lot of people start questioning, why is Flutter so great? And you cannot give these talks everywhere. So he wrote a thorough blog. It's a 15-minute read. So take out your time and read this. And it tells you everything you need to know about what's really revolutionary about Flutter. Then the next big question is, Kotlin is a highly popular language. Why didn't Google go for Kotlin when using Flutter? So he wrote another blog, why Flutter uses Dart. That answers all your other questions that why I couldn't use Kotlin and why it's specific with Dart. So this means that if you were already sold on the idea of cross-platform framework, I hope that now you're sold on the idea of Flutter as well. And with Flutter, you can finally say yes to your designer. You don't have to limit their imagination. There needs to be no restriction. Whatever the designer can think of, you can build that in your Android and iOS apps. So I hope it's the silent hero we deserve that we should have had a long time ago, but it's not too late. So I hope all of you here at Mobilization are excited about Flutter, and the community gets to see some great apps really soon. Thank you.
What is the code base around the Flutter? I mean, tools like test unit frameworks, like our ARM frameworks, is it complete and pretty, major?
So the whole Flutter framework is coded in Dart. In the engine, it uses C++. That's what Skia uses. Other than that, it's all Dart, the renderer part and everything. Was that your question? Sorry.
Yeah, thinking more about... Are there any common good solutions? Like Android introduced Room recently. And I wonder if there are that convenient tools to use in Dart or in Flutter in general.
So you don't have something exactly as Room in Flutter, in Android as in Flutter, but you have some other database libraries and plugins that you have for Flutter specifically. So that's what I said, the community is great. You don't have everything immediately. Room came out 10 years later. So with Flutter, that will come, but there is great support for that. Alibaba built their whole app. They wouldn't have gone for this if it wasn't great. So they don't have Room specifically, but they have some alternative.
You said that one of the commercial apps uses Flutter as a separate module for some features. And how we can use Flutter for some features when we are using, an example, MVVM on MVP, how they can cooperate with our view models or presenters, and what architecture patterns are used for Flutter.
So I'll start with state management. I've used Redux, I've used Scope Model, and there's a great state management tool called Block. It's business logic component. So for state management, you have that. For architectures, trivial ones like MVP and MVVM, people are working on their own. If you have an Android and iOS app that is using one of these architectures, you get those method channels to integrate that with Flutter. So you won't have the same architecture on Flutter that it's implementing MVVM just like your app is, but whatever component of your app you want to do it in Flutter, just pass it using the method channels, and you can achieve that in Flutter.
Well, my question is about using the custom SDKs. You show on some screen that it is possible through some special object, yes? But actually, how difficult it is to create this kind of bridge in React Native? You have to create the special bridge components to communicate with Android or iOS. Natively. So how difficult it is to create this bridge in Flutter?
So in the architecture diagram that I showed, you already have some sensors for location, camera, and some other stuff. If it does not have that in Flutter readily available, someone has already not created that, then you have that method of method channels again. You have that access to the camera and location or other sensors in Android and iOS. You do that part over there, you just transfer the output or get the input from your Flutter component. Everything is not made in Flutter directly. Camera is, location is, but some other sensors are still missing. But it'll come with time. Yeah.
Thank you for the talk. The live coding was pretty cool. So
Thank you.
I'm really hyped up for Flutter. But I'm wondering, what about macOS and Apple Watch? Because I read some articles that basically what's missing is the rendering engine for making it happen. Of course, Apple Watch has a different problem because of the Apple request, the bitcode generation.
Apple is always a problem.
Yeah. So can you tell me if there is some kind of notion people are working on that in the community?
Yes. So I have seen Flutter apps already working on Chrome OS. I've not seen one on Mac OS right now, not an Apple Watch by a far way. But if it's drawing everything on the screen, once those platform-specific problems are fixed, like the rendering one, then nothing's stopping Flutter from drawing on that screen.
Hello, thank you for talk. I have a question. There is some possibility of debugging step by step in Flutter?
Yes. So you have your breakpoints in every IDE. If you have a breakpoint in your Flutter code and you have a breakpoint in your Android code, it jumps from the Android one to the Flutter one.
Okay.
With the same IDE debugging, you get that.
Okay.
What about support for multi-language applications that we need translations, etc.?
Translations.
Exactly.
So I have written a blog about localizations myself. So you have the translations files just like you have strings.xml in Android where you write down all your translations. You can write your translation as JSON objects in Flutter and then read through those according to the language chosen by the user in your app. So you have the translation support.
Thank you for the presentation. Just a quick question. What about Bluetooth?
What about?
Bluetooth. Is it
Bluetooth?
You said about the location. What about Bluetooth?
I'm not sure because on the dev channel, I recently saw a question about Bluetooth printers. So people have gone that far. How do I connect that? But with simple basic Bluetooth, I think it should be there. Dylan, do you think it's there?
Yeah, there's already a plugin from the Flutter team, which does the Bluetooth connection.
So they are covering the basic step-by-step camera location Bluetooth before they go 1.0, so that people don't complain at that time that you're 1.0 and you don't have the basic stuff. Any other questions? Something from React Native, guys? Nothing? Okay, thank you, everyone.